How does progressive collapse destroy bridges? Imagine walking across a bridge and suddenly seeing a section give way without warning. It might seem like a rare event, but understanding how a small failure can lead to a total collapse helps explain this phenomenon. Progressive collapse in bridges happens when the failure of one small part triggers a chain reaction, causing the entire structure or large parts of it to fall apart. It usually starts with a tiny damage, like a broken beam, a snapped cable, or corrosion weakening a key component. When that part fails, the load it was carrying shifts to neighboring parts. If those parts are already weakened or overstressed, they can fail too. This chain reaction spreads quickly, often leading to a sudden and complete collapse. Think of it like a row of dominoes falling, knock over one, and many others follow. In bridges, the failure of a critical element like a support pier or a main cable can set off this domino effect. Corrosion is a common culprit. Steel parts exposed to salty air or water can weaken over time, especially in the top chords of truss bridges or support columns. When these parts lose strength, they can buckle or bend under normal loads, causing failure. Once one element fails, the load redistributes to other parts, which may also be corroded or damaged, making the collapse more likely. Support settlements also play a role. If the foundation shifts unevenly, it puts extra stress on certain parts of the bridge. This added stress can cause those parts to fail, starting the chain reaction. Redundant systems like extra cables or supports are meant to prevent this. But if multiple elements fail at once, the redundancy is lost and the collapse becomes unstoppable. The process usually unfolds in four stages. First, a small, localized failure occurs due to overload, corrosion, or impact. Next, the load shifts to neighboring parts, which then become overstressed. Third, these parts fail in turn, and finally, the entire structure or a large section collapses. Studying past failures helps engineers design safer bridges. They use corrosion-resistant materials, perform regular inspections, and add extra supports to prevent such failures. Monitoring support settlements and fixing foundation issues early can also stop a small problem from turning into a disaster. By understanding how a tiny failure can cascade into a full-blown collapse, engineers can build stronger, more resilient bridges that protect lives and save money.